All right. Good evening. Not sure if many of you will get this. Maybe you'll get it in the morning. But I just wanted to give some answers to some of the study guide questions uh, for our quarterly assessment. And let's see. This joke is something that I think is applicable. Why do trees hate math? It gives them square roots. Anyway, very funny. Okay. All right. Okay, so there's just a few problems I wanted to go over, namely scale factor from one side to the other. Um, okay, so scale factor from A to B, just to remind us that scale factor A to B has to be with a scale factor equation, which is like extremely similar to the proportional equation. Notice I'm going from 16 to 6, so I'm expecting a number that is less than 1 because this is less than 16. So I'm going to spend some time doing 16 divided by 6, sorry, 6 divided by 16. And I'm just going to reduce that. Makes it easy. I'm not going to turn it into a decimal. I know some of you are super efficient at that, but we don't need that. So our scale factor from A to B is 3/8. All right. And then actually the reciprocal from B to A, if I'm going from 9 times something equals 24, if I did 24 divided by 9, and if I simplify that by factor of 3, I'm going to get 8 divided by 3. Look at that. These are reciprocals. So I'm multiplying by 3/8 to get the larger shape to the smaller shape, and then I'm multiplying by 8/3, which is greater than 1 because 3 goes into 8 twice, to go from the smaller shape to the larger shape. So that makes sense because it's getting bigger, and we have a number greater than 1. From A to B is getting smaller, and we have a number less than 1. Okay, now a couple of other ones I wanted to go over. Uh, let's see. Okay. Yeah, let's look at some equations over here. All right. I do have the answers here already, but that's perfectly fine. Um, Here is the mild pepper problem. Does this equation show a proportional relationship? I can definitely plug in numbers, have an XY chart, and then find the constant. However, I could also just use the equation and know whether or not this is thumbs up, this is a proportional equation, or thumbs down, it's not. The proportional equation uses y equals kx form. Notice there's no adding or subtracting anything beyond this one number and then the one variable. The proportional relationship is literally just between two quantities. Okay, so here's a perfect example of what I'm talking about. I'm getting this equation from this table because I know that if I'm talking proportionality, my graph is going to show the constant proportionality where x equals 1. So if I have x equals 1 here, that means that my k is actually the y there because y equals k x, where the x is a 1 value, so 1 times whatever k is, that equals the y. So then this equation is y equals 1 and 75/100 x. And this wasn't asked, but if I did ask you for the coordinate point, it would be this. Okay. All right. Next, if we were doing opposite equations of things, let's just take a look at the order of words. I don't think that I can stress that enough. So Natalie uses 3 cups of red paint, 3R, for every 4 cups of blue. All right, we're going to write two equations. We need to have a first one and a second one to show the relationship between cups of blue paint and cups of red paint. So we know that she if the red paint is X and the blue paint is Y, okay, let's just say we have XY like this, and then we have 3, and then 4, then my scale factor, 3 times something equals 4. My scale factor is going to be 4 divided by 3, which is 4/3. Again, leaving it as that improper fraction because I'm going from a smaller number to a bigger number. So one equation is if R is X and B is Y, which means I'm equaling the number of blue. I'm starting off with the red. And if I multiply the red by 4/3, I will be able to get the blue amount. Second equation is switcheroo and reciprocal. If I am solving one equation for blue, I'm going to solve the other equation for red. So if I'm trying to go backwards here, where I have the blue paint 4, and I need to know 4 times what is going to equal 3, well, then I am dividing the 3 by the 4 because I need to take a fraction of 4 to equal something smaller. So the red paint is going to be the inverse of 4/3, which is 3/4 of the blue paint. Okay, those are my two equations. Those are my two constants. They are always reciprocals. And how much red paint will Natalie need with 10 cups of blue paint? If I'm solving for red paint, I'm going to use this equation. So how many red paint cups? That's R equals 3/4 times 10. I'm going to get 30 divided by 4, and I'm going to get 7 2/4, which is 7 5/10. So with 10 cups of blue, we need 7.5 gallons of red. Okay, and so it's pretty much right there with that. It's right here, 7.5 gallons of red, not gallons, cups of the red paint with the 10 cups of blue. Alrighty. Okay, I just want to spend a few minutes looking at some graphs because we're going to get a lot of important information there. A graph is proportional if it is a straight line that goes through the point 0, 0, which means like 0 of both quantities, okay? And I can find the constant on here because the constant is y divided, and at any point, it's y divided by x. So let's take a look at this really nicely plotted point. Here I have the total cost is the y. So I have total cost 8 divided by 6. And so that is where I'm going to get my constant from this one point. It doesn't have to be the one x value. We're going to get that in a second, but it doesn't have to be that to start. I can use one that is clear that I can just divide. So that's what I want to do. So I have 8 divided by 6, that's 1 2/6, which is 1 1/3. Okay, and so it's 1 comma 1 1/3 for the cost. So it would be like 1 $1.33 for each soda. 1 can, and this is the cost. Okay. So this is proportional because it's a straight line that goes through the origin. All right, let's look at the next one. What's the constant proportionality? If I look here, it's kind of hard to see what's in the middle here. So I want to find a point that intersects both charts. So I'm going to find this point, which is the point 2, 3, which means that the constant is y divided by x. It's the inverse of that. It's going to be 3 divided by 2. What's the constant proportionality? It means that at 1 minute, right, because that's our x value, swimmers have gone 3/2 laps, which is 1.5 laps. Alrighty. All right. And then just the next one. Be aware that like 2 times that 2 sets of information can be on the same graph. and can be on the same uh like table. So that works too. All right. All right, let's take a look at a few problems from Study Guide Part 2, the one that we got today in class. I wanted to go to a few problems that we didn't work on in the class, namely this problem down here where the graph shows the relationship between the distance Dana can drive her car, that's the Y, and then the gas for the number of gallons. So what I'm going to notice is the graph shows a relationship. How much gas will she drive if she drives 120 miles? Well, first I want the constant, and that means I need to find a coordinate point that intersects both and is friendly. Okay, so this is the point 1 comma 25, which means for every 1 gallon, the car goes 25 miles. I'm gonna just write that down. 1 gallon goes 25 miles, so I don't forget and I don't have to like look back at it. But I know that K is Y divided by X, so I'm going to take that as 25 over 1. And that's my equation, Y equals 25X. All right, so that all makes sense. But now if I'm driving 120 miles, which is the Y, I have 120 here equals 25X. What am I going to do? Well, let's get that X all by itself. Isolate, we'll say, and then I have 120 divided by 25, which goes into 124 times, which is 100. And then obviously it doesn't go into 20. So it looks like it's just left over 4 and 25th. So that's pretty exciting. 5 goes into that 4/5 time. So we have 4 and 4/5 gallons for 120 miles. Okay. And so that's how we worked this out. We found the constant, we wrote the equation, and then we substituted in the X value. No, actually in here we substituted in the Y value and then divided, right? Sometimes most of the time we substitute in the X value. All right, let's look at number 8 here. Potato salad price. I don't love potato salad. I like other salads, but I don't know about potato salad. Okay, so looking at the graph, it's told it's proportional. So what does point P mean? Well, point P gives me 3 pounds of potatoes and $15. So I need to find that. Okay, there we go. Then it says at another point on the graph, the second coordinate represents the unit price of potato salad in dollars. What are the coordinates of this point? So the second coordinate is the unit price, which means solving for one of something. So let's take our $15, which is the Y, over the 3 pounds. And what's the result? I'm going to get $5 per 1 pound. Okay, and so here it's just going to look like this: 1 pound, $5. Okay. Yeah, that's it. Let's look at this next one. Constant proportionality. Again, I'm going to look for ones that are absolutely on the intersection, which is 12 over 6, 8 over 4, 4 over 2. So it looks like the constant, which is y over x, is 12 divided by 6, 8 divided by 4, and so it looks like it's 2. All right, so it would be y equals 2x. Whatever I have on the x, if I have 2, plug it in. 2 times 2 is 4. Yippee! Explain how I found it. I found the coordinate point. Okay. Let's look at the farmer and write in the equations. When I read this, I immediately am thinking, what am I solving for? What's my equation? What's my equation? So I know that K, well, that's a formula, but Y equals KX is our equation where the constant goes in for the 1. Okay, there's a constant that goes in there of proportionality, which is what we're like referring to. I'm going to get that from here, where I read the order of the words, which equation can probably use to find how many dollars So if I'm asking to find how many dollars, that's what D equals. That goes on one side. And then how much he would charge for blank pounds of whatever it is that they're talking about. So I need to go locate it. K equals Y divided by X. And I know that 6 is my Y and 4 is my X. Because if on a graph, this is the pounds, that comes before the cost. Because things without pounds can also just lay there. Okay. So pounds cost, that's why it's going up. And in this case, your equation either makes the mark or it doesn't. And Sabrina, yours does too. So which one is it? Right? We're looking for the dollars. And then how many pounds are we multiplying by? Well, it looks like we have 6 divided by 4. That's 1 2/4 or 1.5. So I'm definitely going with C here. All right, and then number 11, just super quick. Number 11 says, which one is proportional? This is not proportional because of +5. This is actually not proportional because, I'm so sorry. Yeah, no, yeah, not proportional. Let me just double check. K equals 3.6 over 3, 6 over 5, 7 2/10 over 8. Okay. So I have 3.6 divided by 3, 1 2/10. Okay. I have 6 divided by 5, 1 2/10. And then I have 7.2 times, or sorry, divided by, shoot, 7.2 divided by 3. What am I dividing by? Oh, 8 here. Okay, and this is 0 and 9/10. So this cannot be proportional. Okay. And yeah. So the only thing left that was proportional is the line segment, which has a straight line, and it goes through the origin, which is 0, 0, 0 of both quantities. Okay, that's pretty much it. There's a bunch of other same things happening over and over again. But I'm very much looking forward to seeing how you're doing. And yeah, get some sleep. Hopefully this helps. If you finish your study guides, I'm happy to look those over and give you some extra points if they're done super well. And yeah, see you in the morning. Night night.